Hello everyone and good morning, good afternoon, good evening to all of you. So basically, today we are going to start basic math series, the second episode. And as you know, in the last episode we have discussed about that CFLCM, the complete theoretical understanding, as well as like what are the different facts and all. Okay, before starting, if there is newcomer somebody, so just we will introduce ourselves. So I am Rohan Kumar Singh from Edu Global Institute, the founder, basically. And why we are, again, I'm just discussing about why we have this basic mathematics series. One of the reason is to make sure that any of the student who is going to see, who is going to watch this series, is being like more perfect in mathematics, and if they have any problem in the basic understanding of the maths, they will figure out. Okay, so today we are going to continue the series, and in the last session we have discussed about HCF LCM. So here we go with the some questions, and whatever the question I'm going to discuss, there are some of about 12 to 15 questions something. Okay, and each and every question are different, like each and every question is very different from like one another. What happened in this one, I will tell you. I'm not going to take a similar level of question. I'm going to take all the different questions which was being asked in the whole series, basically. Okay, let's say till now our these set of questions is being we get through by the doing a proper research that from different olympiads and all, what the different type of question should ask from the HCF, LCM, and yeah, HCF, LCM. Okay, so if anybody who haven't who haven't subscribe this channel, just subscribe it, and if you want to share this to anybody, just they can share. Also, if you want to get one-on-one personalized classes with me, so they can just visit eduglobalinstitute.com or .in. Okay, so there you will see our past year results and everything, and they will just there we have some our published books also, so they can take help. We have some resources also. So let's start by doing the questions first of all without wasting time. So the first question that I'm going to take is this. It's in front of your screen. Okay, look, we are not going to solve the question directly because I know like student usually just copy what I'm doing. So what I will do, what you need to do, just pause your video and look into the question 3 to 4 times, and then try to solve by yourself. Okay, I'm just counting by five. 1 2 3 4 5. Okay, a school has 147 boys and 168 girls, basically. The principal wants to form the largest possible number of groups, basically. Okay, so he wants to form a group, and in the group I know that everybody know that they want to form the largest possible number of group. Let's say in each group they want a maximum number of members should be there. Okay, such that each group has an equal number of boys and equal number of girls. Okay, I understood, there is no problem. How many groups can be formed? Now that's the problem. How many groups can be formed? That's the problem. So first of all, I have 147 boys, okay, and 168 girls we have. Okay, and when we have 147 boys and 168 girls in each and every group, there are equal number of boys and equal number of girls. So obviously when I'm going to form a group, the consistence, the number of people in the group should be very less. It would be 6, 7, 10, 20, 30, but it is less than 147, 168. So as I told you in the previous session also, and I'm repeating it once again, so whenever you need to figure out any smaller number, okay, the HCF is smaller than the numbers, and LCM is greater than the numbers, basically. Understood? LCM is greater than the numbers. Sometimes we can say, yeah, it is equal to the numbers also. Somehow any of the number, maybe A or B, basically. Okay, let's say 3 and 12. If I will figure out the LCM would be 12, so it is equal to 12. So that's why I put equal to sign also. But yeah, okay. So for 147, 168, I'm going to figure out the HCF. So HCF of 147 and 168. So uh, here I will prefer the this one ladder method, and if you want you can just go with the divisibility rule. So 147 and 168, so 7 7 twos are 7 ones are 7 twos are 7 fours are, no, 3 sevens are and 3 eights are. Now you can see I have like this is the maximum number that I can take common, 7 and 3, 7 and 8, now it's completely the co-prime. Okay, so the HCF should be 21. Okay, now number of like look like 21 boys should be in each group and 21 girls should be in each group, there is no problem. 21 boys should be in each group, 21 girls should be in each group. So what I can do, number of boys that should be in each group, how many it's 21 boys, 21, that is also equal to number of girls in each group, girls in each group basically. Okay, now the next thing is number of groups we can form of boys and girls, total number of we need to figure out. So groups of boys basically it's 147 divided by 21, that is 7. Groups by girls should be 168 divided by 21, that is 8. And the total number of groups should be 7 plus 8, that is 15. I think you understood. Okay, so this is how it's done. Just copy it. We will take the next question. The next question, okay, is different. As I told you, each and every question is different to each other. Now what is the smallest number which divides 6, 8 and 12 and leaves remainder 5 only, leaves remainder 5? So the thing behind is I have 6, 8 and 12, there should be a number n which is divided by 6, 8 and 12, it leaving remainder 5. So obviously n should be greater than 6, greater than 8, greater than 12 also. That means I need to figure out LCM. It's very obvious. Okay, so LCM of 6, 8 and 12. I can say it's 24. But now it's not n because there should be remainder 5. If I will divide 6, 8, 12, so I will got 0. To have a remainder 5, so I will add 5 to this number, so I got 29. Now if I will divide 6, 8 and 12 each of them by this, so I got the remainder 5. That's it. I told you like it's literally very easy to understand and collaborate. Okay, this is one of the question, and this is not asked in any of the contest, but I will prefer that you will learn because it is asked in school level exams. Okay, HCF of two number is 11 and LCM is 61693. So HCF is 11 and LCM is 693, and one of the number is 77. So I will say A should be 77. I need to figure out B, the other number. So I will just apply the formula HCF times LCM, that is equal to A times B. What's the value of B? B should be 11 times 698 divided by 77. 7 7 nines are 63. This is, oh, 693, sorry, this is 693. I just forget it, 693. Okay, so 7 nines are 63, 7 nines are 63, so the other number should be 99. That's it, that's easy to solve. Okay. Now the next question is like let's take the next question, this one. What is the least number of identical cuboid blocks, each measuring 30, 40, 42, and 48 centimeters, required to form a solid cube? Now, most of the student will confuse whether they will think like they need to form a cuboid. But let's read the question very perfectly. There are cuboid blocks. Okay, by using these blocks, we need to form a complete cube basically. So how, what, like least number of identical cuboid blocks I want to form a solid cube basically. So if anybody like just having the answer, just they can just let me know with the help of like just go to the comment and type the answer. Okay, now look, as I told you, like I want the minimum number of things. Okay, so it's obvious, stacking the different cuboid, I got a cube, and cube should be greater in size as compared to cuboid. So what I will do, LCM of 30, 42 and 48, and what should be this, 30, 42 and 48, 6 5s are 30, 6 7s are 6 8s are, okay. Now I will just multiply them directly, I will got 1680 centimeter. Okay, now the how many like different number of blocks I require, as I told you, because so first of all, volume of cube should be 1680 times 1680 times 1680 divide by 30 times 42 times 48. It should be uh 0 0 3 5s are 3 6 are 4 0, and it should be something 35. So 56 times 40 times 35, I will got 78400. That is the total number of cuboids which we require. When I'm going to stack it properly, I will got a cube basically, and that is the least number. That is the least number. Or sometimes you will get the hint that we need to figure out the LCM or HCF, okay, in the given question or not. Okay, now uh, let's go with the next question. Here we have the next question. It's like sum of two numbers is 216. Okay, and we need to figure out sum of two numbers. So let's say A and B are the two numbers basically. So sum of them, A plus B, should be 216. That's it. HCF is 27. HCF is 27. How many unordered pair of number exist? Unordered pair of number exist. Okay, now here we are going to use the fact. What's the fact is, okay, listen to me very carefully. I told you when I got a HCF and I'm going to divide with both the numbers, the resultant, okay, we got is the coprime. Understood? So let's say A can be written as HCF times X and B can be written as HCF times Y. So when I'm adding A plus B, so I have HCF in the common, X plus Y, that is 216. HCF is 27, X plus Y I will write down 216, and okay, the number should be X plus Y is equals to 8. X plus Y should be equal to 8. Listen very carefully. Now, now what is the, because it was asking the unordered pair. So for the unordered pair, okay, we need to go. So look, so let's say 1 and 7 will work because 1 plus 7 is 8. 2 plus 6 also work. 3 plus 5 also work. 4 plus 4 also work. Now I can't switch because it's not ordered. It's unordered. We are not going to order. Unordered means we are not going to order. Okay, 1 7 2 6 3 5 4 4, that's enough. But now again I need to choose. I told you x and y should be coprime. X and y should be coprime, and these are the possible values of x and y because x plus y is 8. This one is valid, this one is invalid, everybody knows, because here HCF becomes 2 again. This is valid and this is invalid again. Okay, now valid are 1 7 and 3 5, but remember this is not the number. Why? Because these are the uh, final term after dividing A and B by the HCF. So I need to multiply by HCF, that is 27. Okay, so the number should be 27, and 189. One of the number is this, other one 81 and 135. We have two numbers. Understood? So exactly we have two sets. Exactly we have two sets, or we can say unordered pairs basically. Okay, now we will go with the next question. Find the smallest integer. Okay, this one question is bit complicated, and most of the student will solve this question with the help of you can say uh, by modular arithmetic. But I am, as I told you, if the student has a good ability to apply this further, understood, apply this further with the help of HCF LCM, so they don't require the modular arithmetic. I will show you here. I need to figure the smallest, in which when divided by 8, 12 and 15 they will leave the remainder this. So that means there is n. When it is divided by 8, the remainder I got is 5. Number is divided by 12, remainder I got 9. Number is divided by 15, remainder I got 12. Okay. So now what I will do, 8 minus 5 will be 3, 12 minus 9 will be 3, 15 minus 12 will be 3. I subtracted the divisors with their remainders, and I got a common, that is a constant, the constant difference. It's called the constant difference. It's called the constant difference in different cases. Now, as you know, like we need to figure out the LCM. It's very obvious, because ultimately the number that I want, it's greater than 8 and 8, 12 and 15. So LCM should be of 8, 12 and 15. It should be mm, 8, 12 and 15. 2 fours are 2 six are 15, 2 twos are 2 threes are and 15, 3 2 1 and 5, 2 fives are 10, 10 threes are 30, 30 and 4 120. I got 120 as the LCM. That is good. But now what? I got 3 as the constant difference. Remember that. Remember that we have the different remainders. If I will add 3, if I will add 3, it's very absolute that when I will divide 123, because 120 plus 3 I will, okay, I got the remainder 3 in every case, but I don't want that. I want something different, because I want the difference. So in that case, when your remainder is different, so don't need to do anything, just subtract the common difference you got. Okay, that is 117, and you will see that in each and every case you will get the different remainders. That is one of the fact. Understood? Any doubt you have, you can just give me type on the comment. Okay, there's no problem. Again, I'm just telling you, if you're liking the way I'm teaching and the different questions we are practicing, because we don't have that much time, we only public only 20 25 to 30 minutes videos. So what happened, we have a very limited time, okay, right now. And if you really want that you will get personalized one-on-one customization curriculum study of mathematics with me, so you can contact me directly. My contact number, my WhatsApp number is +918272891238. Okay, you can directly contact me, and also you can visit eduglobalinstitute.com. eduglobalinstitute.com. Okay, I just eduglobalinstitute.com, and you can just register, or fill the Google form, and like place any appointment according to your availability, and we are available for any of the state or region based students, whether it is in US, UK, wherever it is. Okay, so you can contact us. Okay, now it comes to the next question. As I told you, because today we are going to perform each and every type of question here, and the level of question should of each and every question should be like perfect, okay, for any type of contest. Now the next question should be the LCM of two numbers is 24 times the HCF. So I will say HCF is x, so LCM should be 24 times x. As I told you in the fact in the previous session also, LCM is always divisible by HCF. Okay, HCF can divide LCM perfectly. Sum of their HCF and LCM is 500. So HCF plus LCM is 500. So x plus 24x is equals to 500. It's 25x is equals to 500. X is equals to 25 to the 50, 0. X is equals to 20. It's obvious. So I got HCF as 20 and LCM as 480. Now, if one of the number is 120, find the other number. And that's it. Because here we figured out the HCF LCM and only we need to, one of the number is 120, then what's the other number? Yes, that's it. We figured out. We figured out. Okay. You know like what you need to do. A times B is equals to HCF times LCM and you will get your result. Because one of the number is 120, A is equals to 120. You need to figure out the B basically and that's it. You can do easily. There is no problem. But what the question that I'm going to ask right now is bit different and you will face problem here. And I think most of the student don't know how to solve this type of question. What is the HCF of this? Understood? HCF of a fraction. HCF of a fraction. Let's say I have HCF of A over B, C over D, and E over. How I'm supposed to figure out it? It's very obvious that HCF of A, C, E, that means numerators, or we can say HCF of numerators over LCM of B, D, F. So I can say LCM of denominators. HCF of numerators and LCM of denominators. It's very obvious. You can just figure out the HCF of 246, that is 2, okay, and LCM of 3, 5, and 7, 15, 7, 105. That's it. Okay, but why we are going to take the next question, I will just let you know directly about if I need to figure out the LCM. What we need to figure out? LCM of the fractions. Then what you are supposed to do here? Just nothing. Just opposite of this. If you need to figure out LCM of fraction groups that we have, okay, so you need to figure out LCM of numerators and HCF of denominators. That's it. So LCM of 246 is 12 and 357 HCF is 1. That's it. Nothing else. So in the same question we figured out how to figure out the HCF of a fraction and LCM of a fraction. Okay, we don't told you that what we got. This one question is literally amazing and I usually prefer that these type of question most of the student I have seen like they will lag, they are not able to understand, I will say. Now what's the thing is, n is the greatest number. What I told you, n is the greatest number which will divide this, leave the same remainder. So if I will divide 1305 by n, it will okay, 1305 by n, it will give the remainder x. 4665 divided by n is x again. 6905 divided by n, it's x again. It's a problem. but I don't know the n, I don't know the x. What is the sum of the digits of n? Okay, that is also the problem. Let's do this problem. Look, in this case, it's very obvious that we need to figure out the GCD. GCD, because ultimately it's a divisor now. So what I will do, 1305, 4665 and 6905. I'm going to subtract them each other. This one to this one, this one to this one, and this one to this one. Understood? All three are subtracted from each other. Okay? Let's say 4 6 is 5. So what the three numbers I will got? 3360 and 0. I will got 2240 the next, and 5600. Okay? Now, when I got these three numbers I have, I will got I need to figure out the GCD of 3360, 2240, 5600. So what should be the GCD? And GCD in that case would be, you need to figure out 1120. Now check that. Check that. Now if you will divide 1305 divide by 1120, what you will get? 4665 divided by 1120, what you will get? And 6905 divided by 1120, what you will get? In the all three cases you will get the same remainder. That I am guaranteeing you about this. If not, comment me. Okay, but still the question is not ended. They told us to figure out the sum of all digits of n. So 1 plus 1 plus 2 plus 0, it's 4. Sum of all the digit is 4. Sum of all the digits is 4. Now, the next question. Again, it's based on the truly fact. Okay, whatever the question I'm telling you, they are contest based. Their level is good. Okay, and nobody is going to ask complicated than this. Okay, I will guarantee you, not a single question is more complicated than what I'm just giving you in front of all of you. Okay, so just try this, practice this, finish. And if you want to, again I'm telling you, if you want to get the one-on-one personalized discussion, just you can. Now LCM of two numbers p and q is 221. LCM of two prime numbers, oh, that means p and q, I got 221, and p and q are prime. What is the value of 3p minus q? Before this we need to think. 221. Okay, I told you, if there is a co-prime or there is a prime, ultimately PQ are a co-prime also. If they both are primes, so ultimately they are co-primes. So their HCF is 1, then that means LCM is P times Q. That means P times Q should be 221, and 221 is something 13 times 17. Okay, but in the next one it was told p is greater than q, that means p should be 17 and q should be 13. So put the value and you can figure out. I figured out the p and q. Now what is remaining for me? It's completed, it's ended, nothing is remaining for me. Okay, now this is the next question. Let a and b be two positive integers such that HCF ab is 30. So HCF of a comma b is 30. A times B is 54,000. How many ordered pair AB are possible? How many ordered pairs AB are possible? Now, in that case, it is bit different, and I know it's complicated also. As I told you, if A and B and the HCF is 30, so that means dividing A and B, okay. So A can be written as HCF times X, B can be written as HCF times Y. So in this case, it should be HCF times HCF times x times y, that is 54,000. HCF times HCF is its square times x times y, that is 54,000. Then x times y is 54,000 divided by HCF square basically. So I have 54,000 divided by HCF square. So that is 30. So 30 square. 30 times 30. 0, 0, 0, 0, 9, 60. So x times y 60. Now the problem is because x and y should be co-prime because I divided by HCF. So it's completely co-prime. So there is no chance. I can't take any chance here. So what are the possible factors, like groups of x and y? It is 1 and 60. The other one should be, because I told you ordered pairs, so I can order them, shuffle them. Unordered, so I'm not going to shuffle. I'm going to, if 1 comma 60, so 1 comma 60 is there, not 60 comma 1. The other one is 3 comma 20, so I can write 20 comma 3 also. 4 comma 15 also works here because that's look, they are co-prime, they needed to be co-prime. 15 comma 4, 5 comma 12 also, 12 comma 5. That's it. So all over we have HCF as 8, sorry, the different ordered pairs. But if they will tell you that, if tell me the ordered pair of A and B, not X and Y, because look, ultimately they are same. But if I need to figure out the numbers, what are the numbers, what are the pairs, so I need to multiply 30 on both. So 30 and 1800 and 1830, not this, and 90 and 30, 600, and similarly you can figure out for different ones. Understood? Okay, so literally we have discussed maximum different type of questions that was being asked in HCF LCM. So this topic is completed. Okay, so in the next session we are going to discuss a new topic. Just wait, and daily we will upload the video on the same time. So just I will just suppose, I will just believe that you all will come. Okay, so don't forget to subscribe the channel and like if you like this video really, as well as if you think that it's really worth it, and you want to connect with me personally one on one, so you can visit eduglobalinstitute.com, as well as you can visit my WhatsApp number as I told you. Okay, I will give you all the details on the description. You can just go there. Okay, okay, so thank you everybody, have a good day, enjoy yourself, and bye.